right, angles and parallel lines. In our last lesson, we talked about some vocabulary around transversals and all of those things. We're going to, in this lesson, take some of that and put it into practice and learn some theorems associated with the things and basically how, if the lines are parallel, how those different angles and things are actually related. So we're going to start out with a postulate. There is one postulate and several theorems here. Luckily, the theorems are all pretty similar, right? So the first thing that we're going to talk about is the corresponding angle postulate, which says that if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So corresponding, remember, are the ones that go together. And so, like in this example, angle 1 and angle, let me grab a thingy. Yep, there we go. Angle 1 and angle 8 are corresponding. Angle 2 and angle 7 are corresponding. So we're going to do an example associated with this as well, and we're going to kind of talk through if you were doing a problem like this on homework or a quiz or a test, it'd be very likely that in addition to these instructions here, it would also say or list the postulate or theorem that you used, or explain your reasoning or something along those lines. So we're going to talk through the reasoning of these. So for this example, we are told that the measure of angle 5 equals 72. We can probably put degrees on there, make it make better sense. 72 degrees. And so we're asked to find the measure of these angles. This is probably the listed angles is probably a better, or the given angles. So the measure of angle 4 is the first one we're supposed to be looking at. So angle 4 is directly a corresponding angle with angle 5. And so therefore its degree measure is also 72 degrees as well, because angle 4 and angle 5 are corresponding. And the corresponding angle postulate says that corresponding angles have, if it's parallel lines, which it is, and we know that because of these little pink arrows, right? Now, angle 2 is a little different. So because because of what we just said there, angle 4 also equals 72, but angle 2 is not corresponding with 5. So we can't say that because of that, but we can still say that the measure of angle 2 equals 72 degrees. Why can we say that? Well, what are angle 4 and angle 2 to each other? Well, they are vertical angles, and vertical angles are also congruent, right? So by using the corresponding angle postulate and the vertical angle theorem, we can say that angle 2 is also equal to 72 degrees, all right? So let's look at a couple more theorems. First one is going to be the alternate interior angles theorem. So if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So if we have something along these lines, I'm going to draw just kind of a little scrubby example over here. Then the alternate interior angles, so this one and that one, are congruent, right? And then also alternate exterior angle theorem. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is also congruent. So if we had something like this, we'll kind of draw a little bit different version of it, then alternate exterior angles would be congruent. So this one would be congruent to that one, right? Easy peasy, lemon squeezy. So the next one is consecutive interior angles theorem. Now, I said in our last video that I kind of prefer the instead of calling it consecutive interior, I prefer calling it same side interior. I also kind of gave you a spoiler for one of the reasons why, and that is because you can remember same side supplementary. Same side supplementary. Isn't that assonance or something like that? Same side supplementary, right? And that can help us remember that if we have something along these lines, these should all be parallel. And we should probably add little parallel markers, to these, because if it's not written, it's not true, right? There we go. So same side, interior angles, so like this guy and that guy, these two measures, of course, would add up to 180 because that is what supplementary means. Now, the last theorem that we're going to talk about is consecutive exterior angles theorem, and we can remember it the same way with same side supplementary. Oh, hold on. Come back. I'm trying to disappear my layers or something. Same side supplementary. Same idea. Okay, so we're talking about, those are parallel. We're talking about things like this, if we're talking about exterior ones. So maybe this guy and that guy, those two would add up to 180. We kind of look like we've got a bunch of football players going on here or something strange happening. So we are going to look at a couple of examples. Let me first clear off all of this stuff. There we go. And then let's look at a couple of examples using some of these theorems. This is going to be kind of your find the value of a thing type of example. So we're going to use the figure, which looks like this, to find the indicated variable. Now, the indicated variable, we're going to do two different problems. We're going to start with this one right here. If the measure of angle 4, so this guy right there, equals 2x minus 17. So I'm going to start kind of label these. So this one equals 2x minus 17. And the measure of angle 1 equals 85 degrees. We want to find x. So we need to figure out how these two things are related to each other. Are they corresponding? Are they consecutive? Are they alternate? What are they? Well, one of them's on the inside, the interior. One of them's on the exterior. So the only possibility is corresponding, but they're not corresponding because that would be like 4 and 2. So we've got to do kind of a hop, skip, and a jump to get to how they're related. So these two lines are parallel. We know that because little red marks, right? So angle 4 and angle 2 are corresponding, which would mean that this one is the same as that one. So this will be 2x minus 17. Now, how are 1 and 2 related? They're a linear pair. How are linear pairs related? They are supplementary, right? That's the supplementary angle theorem. And so and since they're supplementary, we can say this plus this equals 180. Easy peasy lemon squeezy, right? So 2x minus 17 plus 85 equals 180. Now, it's worth noting that we could get there a different way, right? We could have gone with the fact that 4 and 3 are supplementary, and then 1 and 3 are vertical angles. You can almost always kind of get to where you're going through multiple routes, right? It's kind of thinking like in a city, right? You can get here by going down this street and down there, or you can go down this street and go up there, right? And you can get to the same place. Same idea here. And you just need to find relationships that you know exist and how they exist. So now we've got a really simple algebra problem. Let's go ahead and solve that. We'll combine like terms right here. Negative 17 plus 85. It's the afternoon. I'm going to plug this in the calculator because I don't want to accidentally write something wrong without sanity checking myself. So negative 17 plus 85 is positive 68. Oops. Back to my primary color. Bring down all the things we haven't touched. This is just really simple algebra that we've done dozens, if not hundreds of times at this point. And then to get rid of the 68, of course, we would subtract it because it's positive. Add it on there. So minus 68 minus 68. So those cancel, leaving us with just 2x equals 112. And then to get rid of that 2, it's multiplied. So to get rid of it, we divide it. We divide 2 on both sides. And then 112 divided by 2 is the same thing that what we're using over here. Yes, it is. It is 56. X equals 56. Now, it doesn't ask us to find the used angles or whatever else, but we could have certainly done that, but it just asks us to find the variable. So we're done with that problem. We're going to do one more example using the same diagram and instructions, and then we're going to be done with this lesson. So we want to find y if the measure of angle 3, so that's this guy, oops, jump over there, that's this guy, angle 3 equals 4y plus 30, and angle 7 is 7y plus 6, right? So how are those related? Well, they're like, we don't have to go through 2 different things. Those are alternate interior. How are alternate interior related? You can go back in your notes if you don't remember, right? At least until you have to be quizzed or tested over it. But so they are congruent. So we just set this guy equal to that guy. If they're congruent, then their measures are equal, right? Because the definition of congruence, equals 4y plus 30. So let's solve this sucker for y. So let's subtract 4y on both sides to get those together. And let's subtract 6 to move it to the other side. I think if we keep it neat and organized, we can do those puzzle pieces on one line, especially if we're using our secondary color. So 7y minus 4y is, of course, 3y equals 24. And then we got to get rid of that 3 by dividing it. Divide both sides by 3. Those cancel, leaving us with y equals 8. That's it, ladies and gentlemen. We'll hit more stuff. We'll even hit some more proofs later. But for now, that's where we're going to quit for the day, or at least for the lesson anyway. We'll see you in next class if you're in my class. If not, thanks for joining us. Let us know in the comments how we can help you. Don't forget to like, comment, subscribe. See you later. Goodbye.